Hello everyone, I'm Yuxuan Su from Tsinghua University. Today, I'm going to show our work on transferability of prompt tuning for natural language processing. Before talking about our work, I first introduce some background. In recent years, powerful pre-trained language models have been widely used for many NLP tasks and achieve remarkable performance. Also, fine-tuning became a standard paradigm to transfer pre-trained language model to downstream tasks. However, with the increasing scale of the pre-trained language model, fine-tuning may be not the optimal options, which will cost high computation. Therefore, parameter efficiency tuning methods are proposed. Parameter efficiency tuning methods are only optimize a small partial of parameter for downstream tasks, such as adapter, prefix, DORA, BIFIT, prompt, and so on. Among them, prompt tuning has attracted both research attentions. Prompt tuning prepares some software prompts, which are essential narrable virtual tokens into input sequence, and only trains them while keeping all models parameters fixed. The training object is to generate desired output Y. Prompt tuning can almost achieve fine-tuning performance with only thousands of tunable parameters, while the pre-trained language model has billions of parameters. Although the prompt tuning is an effective approach to utilize extra-large pre-trained language models, it requires more training times than fine-tuning to retrieve the convergence as shown in the picture here. Intuitively, soft prompts are the only tuned parameter in prompt tuning. It may concentrate the knowledge required to serve task conditions on pre-trained language models. Hence, we attempt to improve prompt tuning by prompt transfer across different tasks and across different models. We conduct our experiment in two common series of pre-trained language models, T5 and Robota. In cross-task transfer, we assume that the similar task may require similar skills. Thus, we try to directly reuse them on the target task. As shown in the pictures, the words in the same color indicate the same type of task. And we find the soft prompts can directly transfer to same type task and retrieve and achieve non-trivial performance. However, it is poorly to transfer to different type of task, require different language skill, like here, and this part. Besides, we propose to transfer prompts when initialization. Specifically for target task, we choose the most similar prompt according to zero-shot transfer performance. Then we use it as initializations and start to train. As shown in the table, experiment shows that this method can both accelerate prompt tuning and also achieve better performance. We figure starting the cross-model transferability of soft prompts. Intuitively, our motivation is to train prompts on a smaller pre-trained language model and use them on a larger pre-trained language model, which will cost massive computations. And so it is much more efficient and environment friendly. However, in cross-model transfer, directly using prompts is impossible because the semantic space of different pre-trained language models are inconsistent. Thus, to project the train soft prompt to different semantic space, we train projector with two different objectives and test their effectiveness. The first one, we minimize the distance between the project prompt and the parallel prompt trained on the target pre-trained language model with the same task. The second one, we directly tune the project prompt, PS prompt, on some task and back propagate the supervised signals to optimize the projector weight so that the projector can learn how to stimulate the target pre-trained language models. In this experiment, we use LangTop dataset, which is a sentiment classification task, and MMLI dataset is a language inference task to train these two projectors. From the table, we can find task tuning objectives was better than distance minimizing projectors. Task tuning projector can generalize to same types unseen tasks of the projector training task, which prove the feasibility of practical cross-model prompt transfer. Based on the positive results in cross-task and cross-model transfer, we exploring why the soft prompt can transfer and what decide the transferability between them, which may help us to find a suitable prompt to perform transfer. The suitable prompt can achieve better performance and speed up prompt tunings, like we introduced in the previously. We're exploring the following two kinds of metrics: embedding similarity and model stimulation similarity. For embedding similarity, we take two strategies: concat and the average. The first one, we introduce the concat. We concat to every token embedding for each of prompt, and compute Euclidean similarity and the cosine similarity without the prompt. Second, we compute the Euclidean similarity and the cosine similarity between each of token embedding for two prompts. For model stimulation similarity, we calculate prompt similarity based on how they stimulate the pre-trained language models. Specifically, from the previous work, the output between feed-forward layers, here's the yellow part, and can be regarded as non-negative activation value for neurons. Here is one thing is that we need to feed a prompt. We need to feed a task-specific prompt into pre-trained language model and activate the corresponding neurons, and we denote them as ASP here. For example, we input a task 1 prompt and get a corresponding activate neurons in blue colors, and then we also input another task 2 prompt and get a corresponding activate neurons in green colors. Finally, we calculate the cosine similarity between two groups of activate neurons. To find the best transferability indicator, we compute the Spearman correlation between the ranking by all similarity indicator scores and the ranking by zero-shot performance. We could clearly find that ON model stimulation method has the highest Spearman correlation, which means this is the best transferability indicators. Besides, we also observe that ON worked worse on the larger pre-trained language model. We guess this is because the larger pre-trained language model have a higher redundancy. Further, we're exploring the distribution of activated neurons. We showed the activated neurons in diverse layers, and we can find in the top layers, the top layers have a clear cluster than bottom layers, which means the activated neurons are common in the bottom layers, but it's more task specific in the top layers. We summarize 3 points of our work. In cross-task transfer setting, soft prompts can transfer to similar tasks to accelerate prompt tuning and achieve better performance. In the cross-model setting, software prompts can transfer to different pre-trained language models with the trained projectors. For transferability indicator, we can utilize activated neurons of soft prompts to measure transferability between tasks well. Thank you.